Hey, Bitson!
Oh, hey Romaldi.
Yes. How is work going?
Work's been going okay today. But I was just really deep in thought earlier. You know, I really wish there was another method we could use to harden concrete, as in to prevent it from breaking, aside from using reinforcement bars. Get what I mean?
Yeah, I wish there's something we can do to reduce the cracking in concrete.
Yeah, me too. If
Yeah,
only.
yeah. One day though.
Alright, so that's the plan. You got that?
Alright, yes, I got it.
Okay, so I guess we could call it a day, Ralph.
Alright, sure.
See you later.
Let's see.
Listen.
Huh? What do you mean?
My bad. I was dreaming. Huh. Early crack prevention. Fiber aids in controlling sinkage cracking as the moisture level changes when the water evaporates from the concrete. Fiber concretes prevent or at the very least reduce early cracking right from the start. The other thing is it helps in durability and strength. The addition of fiber increases the overall durability of concrete. It can also help lower corrosion level, cavitation damage, and has a higher level of tensile strength when compared to other non-fiber concrete. Huh? What is fiber reinforced concrete?
Huh? You don't know? Our project is literally about FRC.
Oh.
Okay, so in basic terms, fiber reinforced concrete can be easily defined as a type of concrete which contains fibers. Now, these said fibers, which can either be made from steel, glass, or synthetic polymers, are uniformly distributed in the concrete mix, or in a composite concrete mix that hasn't been hardened. The concrete must be softened and must be pre-made. Now, the primary function of these fibers in the concrete is to increase the concrete's overall properties, like the concrete's tensile strength, or the concrete's ability to reduce cracking and shrinkage. And lastly, it's also used to increase the concrete's impact force, or in other terms, durability. Now I know what you're thinking. These fibers sound very similar to reinforcement bar, and you may think that it can replace it, but in reality, that's a lie. Fibers are no replacement for reinforcement bar and are not a primary use to harden concrete. This is because the fibers themselves do not aid or help the concrete's overall flexural strength or help the concrete's ability to bend without breaking. And believe it or not, some fibers even reduce the concrete's strength. This happens when said fibers are not distributed well enough in the concrete. Now, this defeats the whole purpose of adding fibers in the first place, because what for will we add something to enhance the concrete strength when it's not even going to aid the concrete strength whatsoever? Now, of course, even after all of this bends down to how well the fibers are distributed or what fibers are used in the concrete or in the process of making.
And also,
there are many types of fiber reinforced concrete. Firstly, steel fiber reinforced concrete. This type of concrete is known for its high tensile strength and is often used in industrial flooring. Number 2 is glass fiber reinforced concrete. This type of concrete contains tiny fibers and is commonly used in construction industry. Number 3 is carbon fiber concrete. Carbon fiber are lightweight, have high tensile strength and stiffness, and can withstand extreme temperatures. Number 4 is polypropylene fiber concrete. This type of concrete use polypropylene concrete, and which synthetic fiber made from propane. Polypropylene improve concrete mix cohesion and resistant to abrasion to concrete. Next is asbestos fiber concrete. Asbestos are resistant to chemical, heat, and mechanical stress. This making them suitable for corroding roofing elements, tiles, and sheet product pipes. However, they are low impact strength due to their short length.
Bro, focus. The boss is coming.
How is work going, guys? Okay, as you guys know, Isaac, I want you to present your work in front right now.
So fibers. When fibers are mixed with concrete, it can actually greatly improve its tensile strength. As you all know, tensile strength, concrete is not really great at handling tensile strength, but with the help of fibers, actually can. So the fibers acts like a reinforcement in the concrete. It bridges the cracks and also help resist the tensile force. The other thing is it can also help in increasing the flexural strength of the concrete, essentially a bending. So you know concrete is not really meant to be bent. So with the help of fiber it can help bend it a little. So the fibers helps to distribute the bending force and also resist the crack propagation. So the other main thing is fiber can significantly improve the toughness and also the ductility of concrete. So basically, after cracking, the fiber will continue to bridge cracks, thus allowing the material to absorb more energy and to prevent from sudden failure. This will make the concrete less brittle and can withstand more larger deformation until sudden failure. So the main selling point of fiber is that it is a great alternative for steel rebar. So essentially both of them just the same thing, but fiber is a little bit worse, not worse, but not as good as steel rebar. But it does the same. But the main thing is it is much more cheaper.
That's awesome, Isaac. So, as we all know, the fiber reinforced concrete is high in tensile strength, but there's also various factors that can affect the property of fiber reinforced concrete. For example, first, the type or characteristic of fiber. Second, the concrete mix design. Third, fiber matrix interaction. And fourth, the curing condition. Next, the other factors that can influence the property of fiber reinforced concrete are loading condition, environmental factors, and workability. Other than that, crack behavior and toughness, construction, and placement. That's it. Isaac, coffee?